Hello friends, welcome to my channel. Let's have a look at problem 2046, sort linked list that is already sorted using absolute values. So in this video, we're going to share a solution based on linear traversal with check. So the solution we are going to share is going to be O1 in space and On in term complexity. So with that said, first I'll read through the statement of the problem to digest the requirements, and then we do some simple analysis and finally share the code. First, let's look at the statement. So given the head of a singly linked list that is sorted in non-decreasing order using the absolute values of its nodes, return the list sorted in non-decreasing order using the actual values of its nodes. So here are three examples. So before we look at the examples, let's first specify our idea. So the idea actually is very straightforward. When we meet a negative number, we put it before the head. So in other words, put it at the very beginning of the linked list. So this way, after we do the traversal and make these operations, the linked list, the resulted linked list, will be sorted according to nodes' actual values. So let's look at example 1 in some details, because example 2 and 3 are sort of special. So in example 1, so when we check, so when we have -5, so what we are going to do is that we break the link between 2 and -5, and the link between -5 and 5, and then we connect 2 with 5 and move 5 in front of 0. So we will have -5, 0, 2, and 5. And then we will meet another negative number, then we put it in the very beginning again. So we have -10, -5, 0, 2, 5, 10. So that's example 1, so which actually demonstrates the generic case. So with that said, let's look at the constraints or additional assumptions for this problem. First, the number of nodes in the list is in the range 1 and 10 to the power 5. So this constraint actually defines the size of the problem. And the second constraint is on the node value. So the range of the node value is in between -5,000 and +5,000. And the last constraint is that the head is sorted in non-decreasing order using the absolute value of its nodes. So this actually already specified in the body of the statement. So here is also a follow-up. So can we think of a solution with On term complexity? So the solution we are going to provide will be On in term complexity. So with that said, we are ready to look at the method. So we're going to use the standard linear traversal, but with some check. So the idea is the simple one. So when we meet a negative number, we put it to the very front. So the procedure is the following. So in order to fix the idea, so here I pick one piece of nodes from the example 1, and also we use a dummy node to help do the implementation, and also we use this dummy as a reference node. So each time we want to put a negative value node to the very beginning, so we just need to put it right after dummy. So here is if we regard this head as dummy, then what we're going to do is that we check the next to see if its value is non-negative. If it's not non-negative, we just move head front. So we just move forward. So once we find the head next has negative value, so we need to break the links. For example, the link between 2 and -5 and -5 and 5, and then we connect 2 with 5, and then we let 5 point to 0 and dummy point to 5. So these operations are summarized here. We are going to save head next to temp for later use, and then this line of code actually did two things. First, break the link between 2 and -5 using the example here, and then connect 2 with 5. So this is this line, and then we're going to break the link between -5 and +5, and then connect -5 to 0, right? So this is the line here. And then what we are going to do is that we connect dummy to with temp. In other words, we set dummy next to temp. So after these operations in this cycle of traversal, the result will be dummy -5, 0, 2, and then continue. So 2 is the current head state, right? So as we mentioned, we only use in-place operations in this solution. So the space is O1 and temp is ON, where n is the linked list length. So with that said, so I guess we are ready to write this code. So now the task should be straightforward. So basically we will translate the procedure into code format. So for this purpose, let me first instantiate a list node. So with value, let's say equals 0, and next to be the original head. So this is one thing. So the dummy node plays two roles. First, as an hypernode to help us do implementations, and also it serves as a reference, right? So each time when we meet a node with negative values, we will move it right after dummy. So this is the same. First, let's do a special case check. So if head value is non-negative, then we can point the head to be dummy. So this is the preparation. Let's call it step 1, preparation. So next we are going to do the linear traversal check and repointing. So this line actually specifies the operations we are going to do. So we are going to check val head and head next. So first, I'm going to treat a special, very simple case. If head next value is non-negative, then we just move head forward. So head equals head next. So this is the one case. In the other case, the head next value is negative. In other words, we meet a negative node. So in this case, we want to move the nodes with negative value in front. In other words, right after dummy. So this actually is very, the goal is very clear, but we need to do some reset and breaking links. So for this, I'm going to first get head next and store it as temp for later use, because we need to break links. So then what we are going to do is that we want the head next, so to be head next next. So this line of code actually did two things. First, so this head next reset breaks the link between the original head and head next, and then we point the head next to be the head next next. So this is one operation. Another operation after this is we set temp next to be dummy next. So this line also did two things. First, break the link between temp and temp next, and then we point temp next to be right after the dummy. So the last thing we're going to do is connect dummy with temp. So you can think of example 1, for example, when we meet -5. So that's all the operations we need. Actually, after this, so we can do the return. So we are going to return dummy next. So this is the one row of dummy, and here is another row of dummy as a reference. So with that said, we are finishing the format of the solution here. So now let's do a special case check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So this solution format is in place, and its temp complexity is ON, space complexity is O1. So I guess with that said, that's about it for this problem. You are welcome to check out other videos in my playlist or in my channel. That's it for this video. Thank you very much.